We had a conversation the other night trying to think about the structure or the how we could classify some of the recommendations that are coming out of the workshop so far. And so we revisited this type of time-space diagram that you see on the right. And based on the session summaries that we've heard from yesterday and today, one way that you might classify some of the recommended observations is some might be described as fine time-space scale processes. Some recommend high-frequency observations over time. Some focus on multi-scale interactions. And so we want to encourage participants to think about where in this diagram do these processes live. So for example, the fine scale processes are shown as these little red circles in the red box. Those observations that are needed over time are represented by the orange arrows. And then the multi-scale interactions are the two-sided purple arrow. And so this sort of lays out where our observing needs fall into this time-space diagram. And the next challenge is to think about how can they be observed. And so with a nod to Samantha Wills for sort of illustrating this, we have, for example, the TPOS array on the right, adaptive observing platform somewhere in the middle. But you'll notice in this lower left corner and on the far left of this diagram, there are still some areas that are not covered. And so what we really want people to think about is, as you identify observing needs, where do they fall in this space? But also what kind of recommendations might emerge from considering this distribution of needed observing systems. So we're going to ask all panels that meet later today to spend the last 15 minutes of their session thinking about where you would place these observing needs on a diagram like this. So the three broad categories that we've listed here are not definitive. You may decide they should be rearranged or reorganized. And that's exactly the kind of input we're looking from here. But we wanted to introduce this just to give you a little bit of framework to help us organize the recommendations that come out of these workshops. So we will show this figure again before we go to breakout sessions, and it will be included in the summary slides for each breakout session. So with that, I will turn it back to Anish. Thank you.
We had the 4 different breakout groups all in the same theme. We will go in the order that was labeled. So I think the breakout session A was moderated by Kelvin.
Okay, so we had a lively discussion. Hopefully I will do justice to that discussion by going through these notes. I guess we spent most of the time on this first set of questions, looking to GCMs, and those GCMs have unresolved processes in the form of vertical and horizontal mixing. There are biases in the cloud SST feedback, and in order to utilize paleo climate data, we need to expand the present-day observations of isotopes. I think one thing that was stressed is that when looking at the performance of a model, we're often looking at the emergent property that is due to processes within the model, and it's unclear in the model context what is needed to to improve the processes that result in this emergent property. So what is needed are process studies and targeted observations to establish things like the functional relationships between shear and turbulent fluxes that give rise to this behavior. And in this context, data assimilation, both in terms of state estimation, but also prediction, can be used to look at how small changes to the system propagate within the model and point to key space and time scales and processes that are important. I'm a big fan of, in terms of process studies, I'm a big fan of putting time and effort into long time series rather than spatial coverage. And what we need are a number of long time series where processes are properly resolved at a number of sites spanning the Pacific, and that sample the system in different regimes. Yes, we need co-located atmosphere-ocean observations. There was a plea to increase salinity observations in order to get a better understanding of the role of salinity in stratifying the upper ocean and the impact on air-sea exchange. The vertical distribution of stress needs to be measured on a number of vertical, spatial, and lateral timescales. And over what depth does the wind influence the ocean? Of course, we need to establish what the observational error is, especially for data assimilation models. And the last bullet point here is something I cannot emphasize enough, and that is vertical resolution. Both in observations and models, we're often severely underrepresenting the vertical processes. And we need to establish what vertical resolution is needed to capture the relevant processes in the system. Next slide. This one, we felt we could not really add very much at all in terms of how to measure these things. We have discussed the use of ships, moorings, autonomous vehicles, satellite, etc. The next question, next slide. Yeah, so process studies are needed to determine the representation of error in data assimilation, for example, in determining what temporal variability one is missing in a 10-day float, in the 10-day float data, or spatial variability from moorings. And the next slide. In terms of information going the other way, then obviously in planning and also interpreting results from a given process study, the larger scale network is needed to inform in terms of the background state, and also gives information on where and when process studies are needed to explore these different background states. There's a question of how representative the ocean atmosphere state is when and where the process study takes place, which relates to the first point. And it can also inform on the size of the state space that needs to be explored with process studies. Also informs in the scale interaction, and again, going back to this concept of emergence, how a process happening at the smaller scale it emerges on the larger scale. And if we go to the last slide, we did not leave 15 minutes to discuss this particular issue, but we would like to make a couple of points, and I think the first one is most important. So at the bottom bullet point that we have here, I think in this diagram we need to have another axis, and that is the vertical scale. The vertical scale of processes varies both in time and space, and it's important that we are resolving that vertical scale when we look at particular processes in this space-time continuum. And there was a comment that I don't know if it's particularly important, but there's the rectangle for TPOS isn't really a rectangle in that certain areas of that rectangle are not covered. For instance, we don't get 100-kilometer resolution, spatial resolution at 12-hourly intervals. Okay, that's all I had to say. Thank you.
Thanks very much, Kelvin. I think we'll move to the next breakout, which was moderated by Dongxiao.
Hi, everyone. Yeah, we had very lively discussion, and we touched upon a lot of topics. We didn't have time to put everything together, but here is the main points. We are going to continue to fill in the gaps, make more comprehensive recommendations in the next couple of days. But we talk about the panelists and the participants have all agreed that co-located and concurrent observations in both physical and the biogeochemical space are important because, I mean, for example, in physical components, you have atmospheric model, you have ocean model, you have in the ocean, you have oxygen component, you have the carbon component. Very often, you fix one component through any type of parameterization, and the other component failed. And fundamentally, many of the components are linked by the same process. For example, the mixing process. If you want to look at some examples, for example, if you want to look at the LC fluxes, I mean, they are connected by many phenomena. The cold pools, convection, the turbulence in the atmosphere and ocean boundary layer, thermocline, the surface waves, the current, the state variables of fluxes and direct flux measurements. We separate this out because direct flux measurements are very difficult to make and more expensive, while the state variables are more approachable for long-term observation. So we talk about the scales. With all the newer technology, the emerging technology of the UXS system, the unmanned systems, we can go down to a few hundred meters with a group of USVs, for example, 200 kilometers in the horizontal space. That has not been possible before for long-term observation. We also talk about the vertical space. We in the tropical Pacific, we understand 500 meter is pretty critical, where you have oxygen minimum zone in between 200 to 300 meter, and you have the thermocline from the west to east about 200 to 100 meter. While in the atmosphere, we talk about the convections, the cold pools. We're asking them about 10 kilometer, the cloud base, for example. We also talk about the importance of isotope measurements. Would be great if it can be made available from the shape, buoys, or islands. Probably not small enough for the USVs for now. So the emerging technologies, the USVs has been really progressed a lot in the past 5 years, and we can deploy as a network to target some regions to fill gaps in between fixed observing platforms. We can pilot gliders for process study. Remote sensing also has been improved in the past few years. That can be used, for example, some historical measurements of remote sensing can now be used to detect cold pool. There's a newly proposed butterfly mission that can make better measurements at the LC interface. So in situ observations from UAVs, the air drones are become available. These small UAVs can take vertically from shape from research vessels. So next slide, please. So how can we leverage observation? It's a different type of observation, process study and long-term observation. So we really encourage to gather data on the transits of cruises. We like to combine different type of observing platforms and remote sensing to fill in the gaps that we have had in the past. A couple of examples, can we get rolling sound system on the ships? Can we launch balloons on all the cruises? Obviously, this need funding support, but these are the opportunities for the scientists to take advantage of. Next slide, please. Yeah, so how do we do that? We need to combine long-term measurements with short-term field campaigns. The intent is to build a continuous process study. So it's a continuous process study. So the interesting concept. We can, some components of the process study can be involved into the long-term observing platforms if needed. Next slide, please. So some other themes that emerging from the discussion, which is actually really critical for the observation. We have different platforms, newer emerging technology, traditional platforms. The accuracy of the measurements from the different platforms and instruments need to be well documented and intercomparable. Next slide, please. Some recommendation. So in order to take advantage of the sustained observation, we need to better organizing among scientists to take advantage of the opportunities. Yeah, we had a short amount of time to talk about this diagram. So we fill in some, we feel that the surface waves and the temperature salinity in the barrier layer, the turbulent heat fluxes, the skin temperature are all important on the fine time scale. Processes, for example, mixing in the ocean and the atmosphere are important. Cold pools, atmospheric entrainment, upwelling, subtropical cells. It has been the old problem, but we haven't really, advanced too much. At least in the models, it's still problematic. Sustained high frequency observing needs. The wearable, we want to differentiate between some wearables that can be easily measured, that can be sustained. For example, the state variables that can be used to calculate turbulent fluxes, turbulent heat fluxes, and water isotopes is also important that we want to have. So the time scale is hourly to planetary scale. We have talked about in the previous slide. The multi-scale interaction observing it, we want to leverage between ocean and the atmospheric program funding agencies. I think that's all.
Thanks, Dongxiao. I think we'll move next to Janet for the third breakout session.
Okay, so we also had a great session. We had 23 people, and I want to thank the rest of the panel and Mike Patterson for taking notes here. So we talked about, as others have talked about, what scales should be considered and how important it is to co-located and simultaneous ocean atmosphere measurements. We put the emphasis on turbulent exchanges, surface fluxes, and also transports in both the upper ocean and the lower atmosphere. We thought that there was a range of technologies that could be put together to provide a unique capability to measure these localized scales over the vertical continuum, and that could be actually envisaged to be done by many of these platforms over a broader spatial scale. We talked about how flux parameterizations need to resolve the small scale processes near the interface, but also the nature of the models where there's issues of averaging over these small horizontal space and time scales. And then also the importance of the coupling of these new surface variables, such as occurs in cold pools and Langmuir circulations. And we were uncertain how the models treat these different phenomena in flux parameterizations. We talked about the need for improved temporal and spatial resolution in targeted ocean regimes. So that's come up a number of times in our discussions over the last 3 days, and that requires increased density and therefore resolution of observations especially for data assimilation. Especially when we talked about a couple of different case studies in terms of how that could act to improve monsoon prediction, even in the Indian Ocean, based on Pacific Ocean background, and how even I'll stop there. And then from an ENSO prediction perspective, ENSO really requires measurements from throughout that OA continuum, from the lower boundary layer of the atmosphere right through to the thermocline, as well as interaction of off-equatorial and the equatorial region also being important. Next slide, please. Okay, emerging technologies. We like this question, but as others have talked about, we've talked about, we focused in our group specifically on remotely and unpiloted technology, and the ability of that to have adaptive sampling, right? And so that gives some flexibility to measure scales from 10 metre to a metre, and then also allow for adjustments using that platform, using those mobile platforms. And so we thought that was really beneficial to have these platforms that can move, but then also have the ability to be semi-stationary when we encounter a phenomena we want more information about. And we're on the golden age of miniaturization, and so that gives us some opportunity to modernize our observing system, and we should take advantage of that. And in fact, we talked about the realistic timeline for these new technologies to emerge, but some are ready now, as we've heard about during this workshop. And the ones that are related to AI decision-making are really in early stages, but making very sound progress in initial tests and everything. And so we expect more of that testing in the next few years. And mostly UVs are not new. They've been around for at least 20 years. And so it's the evolving technology that has been around for a while. So we need to make progress in evolving those systems so that they become more regular tools for us. Leveraging, this is from a process study localized in time and space. Okay, so Chris Farrell, who was in our group, we were lucky enough to have Chris. He talked about how the classic approach is really to make direct measurements and then relate those to mean properties. And to do that, you put out an array of buoys to measure these bulk parameters. And there's many examples like Toga Core that we've heard about that have this approach to surface flux parameterization, and that's a clear argument for centering process studies around the backbone. So that our basic message is the backbone is super important for these process studies. Another example that Chris provided was the opportunity to take ship-based measurements for instance, at the flux reference buoys using equipment that we can't readily deploy on the buoys, such as celiometers for cloud fraction. And that you can use the celiometer for calibration while at the buoy, and then use that to establish the year-long cycle. We thought it was important to get more direct covariance flux measurements on the buoys for verification and calibration, and to improve the accuracies of the bulk formula and as well as the remotely sensed measurements. And then we also like the idea very much, and I've talked about this in the last part as well, of deploying mobile mesoscale networks of observing platforms, little fleets, if you like, little Navy fleets of observing platforms for both long-term measurements on smaller spatial scales, but as well to have them available for use in process studies to resolve targeted phenomena. And so that gives us some flexibility. These little mesoscale networks of platforms give us the ability to observe space and time scales of interest. Next slide. So the existing backbone takes advantage of filling in between the spatial and temporal variability that we don't get from process studies, right? And so but we also, again, emphasize that there's no one perfect platform. You know, we don't want to name, and then a mix of these is really important. We thought that it was good from an atmospheric perspective to have continual sustained observing efforts, like from arm sites and as well as our ships, and you know, and I can imagine that the super site might be thought of like a similar the super site we talked about with the buoy might be thought of like a similar facility for us as marine scientists. Longer time series are also important to inform and address science questions, and particularly they let us to determine the seasonality of phenomena, right? So that we can examine the probabilities of an event occurring, so that we can determine when it is best for a process study to occur that might be, for example, dependent on seasonality. We can also inform new satellite sense improvement and measurement capabilities, such as the proposed satellite for surface currents. Next, please. So, like others, we ran out of time.
2 minutes, sorry. Yeah, feel free to wrap up.
Well, we ran out of time, so you know, we have these are addressing these are the fine timescales observing needs. We identified winds, surface fluxes, surface currents, as particularly at the upper, very near surface, mobile measurements with grids that could move continuously in terms of sustained high frequency observing needs. We thought subdaily timescales, ocean mixing, and having long-term deployments of autonomous platforms in a general regime is important. I'll stop there. That's it.
Okay.
That last slide addressed this
Okay.
slide. There's a bit of a disconnect, but we got there.
Yeah. Great. Thanks a lot, Chad. It's very impressive. Kyla is next for the breakout session.
I'm going to dash through in the last 3 minutes. So thanks to the team, and sorry if I go too quickly to get your favorite point. Some of the big themes that came out in our breakout were water isotopes, which integrate over space and time, so they're helpful for multi-scale connectivity. 3D observations of the boundary layer structure in the atmosphere. And the rapid transition from shallow to deep convection, which happens over many scales. We emphasize the importance of capturing the diurnal cycle in all boundary layer parameters, and fine scale spatial variability of boundary layer measurements in both ocean and atmosphere, where you can define fine scale based on the process of interest, but it should be fine enough to capture the statistics. And the importance of subsurface ocean variables like mixed layer depth and ocean heat content at smaller scales than you can get from Argo. Next slide, please. So a couple of emerging technologies are water isotopes again. The global planetary boundary layer observing system, which is sort of 10 to 15 years out, and microphysics probes and scanning and vertically pointing radars to get at convective transitions. Next slide, please. A couple major points on how we can leverage observations is emphasizing this need for sustained observations to generate statistical distributions and understand variability. And it's also really important to revisit existing field campaign data. There's a lot of data out there, and those can be analyzed right now to get at statistics and better understand models. Next slide. We didn't have anything. Next slide. Okay, so some themes was guiding observing strategies with model biases, consider outcomes that are relevant for stakeholders. Again, this need for long-term observations, and as well as matching observed statistics to model statistics in capturing observations. And finally, the role of the atmospheric mesoscale is necessary. And then the last slide, oh, no. Yeah, there we go. So mesoscale systems, the precipitation and salinity connection, cloud microphysics, and ocean turbulence measurements, including the full TKE budget, came out as really important observing needs on small scales. Sustained observing needs are air-sea gas exchange, that 3D atmospheric boundary layer, and water isotopes. And then again, that precipitation salinity connection was one of those multi-scale interaction observing needs. I will stop there so we can end on time. Thank you.